Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing the principle of square roots. Well, the principle of square roots is just this. If x squared equals k, then the two solutions for x, k being a constant, are that x equals positive the root of k or x equals negative the root of k. We often just sort of kind of combine both of these and say x equals plus or minus the root of k, where there's actually two solutions here, but they're combined. And what we really are saying by this is that one way we can solve is that if we just have a squared term, unlike in the previous section we had two terms, that x squared and an x, and we used factoring to solve that. But if it's nice enough, we can sort of use square roots, and we would isolate the square term, and then we can square root both sides to sort of help solve this. Not forgetting that when we square root both sides, we need a plus and the minus. So we need whatever we're square rooting to then have a plus or minus in front. All right. So how do we do this? Well, let's look at this first example. 2x squared minus 10 equals 0. So we were looking when x squared equals k. So here is the x squared, right here. What do we have to do? Well, we have to isolate that x squared to get it so that we can do this method. Okay, so whatever's being squared, the variable, or whatever, if there's a square, then a variable inside, then we have to isolate whatever that is. So in this case, this is the squared term, so how do I isolate? That means solve for x squared. Well, I'm going to add 10 to both sides. And then we have 2x squared equals 10. How do we, again, further isolate the x squared? Well, we need to get rid of the 2, so divide both sides by 2. And we have x squared equals 5. And now we're back to this exact situation. X squared equals k. And what do we do here? Well, we just square root both sides. And when we do, and when this the x squared and the square cancel, we need to remember to put a plus minus in front of here. Because how many solutions do we have? We have two. One where x is the root of 5, and one where x is negative the root of 5, is what's really going on. This is just a simplified notation. Sometimes we may have, especially when the square root goes away and you're trying to simplify, you may actually want to separate it into two actual equations to help further simplify. But these are reasonable solutions. And that's all we have for that problem. But what about number 2? Here we have the quantity of x minus 3 being squared, and then I have plus 4 equals 8. Well, how do we handle this? Using this sort of the principle of square roots. X squared equals k. Well, in this case, we have x minus 3 quantity squared plus 4. So what's being squared? This is. So this whole thing is what we need to isolate before we square root. So we see the plus 4, so we're going to try to get rid of that. So we have x minus 3 quantity squared. 8 minus 4 is 4. And now what we do, we have the quantity that's being squared isolated. Now we can employ the principle of square roots. Square root both sides. The idea here for the future is that the square and the square root sort of undo each other. I say sort of, there's some nuance there. But we have, once we get rid of the square and the square root on this side, this becomes a plus minus, and then the square root of 4 is 2. So, and it's a plus, and we have a plus minus, and the square root of 4 is 2. So this is where I recommend, once the square root goes away, separate it into two equations. It's a good rule of thumb. So we have x minus 3 equals positive 2. We have x minus 3 equals negative 2. A lot of people don't do this, and they have some pitfalls when they try to add 3, and they mess things up. So again, once the square root goes away, and you have the plus or minus separated into two different equations. So here, if you add 3 to both sides, you get x equals 5. And then on this side, if you add 3, again, something very different happens. Negative 2 plus 3 is actually positive 1. So x equals 5 and x equals positive 1 are our solutions. This is all for this lecture.